Hello everybody, Root Beer here, looking at question number 9 on the 2014 Manitoba Math Contest. So let's take a look. Question 9 has a very simple looking statement. Prove that square root of 4 plus 2 root 3 plus square root of 28 minus 10 root 3 is an integer. Okay, now I don't like all these square roots here. So if it turns out that this is an integer and I square everything, I should get a perfect square. Okay, so with that in mind, so 2 root 3, and then it was plus 28 minus 10 root 3. I think that's what it was. Yeah. So I will suppose, say that's k if it is an integer. Well, it isn't, sorry, let's say it this way. It is an integer. If and only if k squared is a perfect square. So if I square this and I can turn it into 100, well then I know that this is just a weird expression for 10. Okay, so, k squared, we get 4 plus 2 root 3, so that frees that up a bit. We also get 2 times, and this is where things get a little messy, and maybe there's a better way to do this question, I don't know yet. But we free up a lot of things out of the square root sign. And, 4 plus 28, hey, that's 32. So, maybe the whole expression here just turns out to be 4 somehow, and this becomes 36. We don't know yet. We get minus 8 root 3, and then plus 2. And the nice thing about having square roots multiplied together rather than added is I can combine them all under the same square root sign. Okay, so we can multiply this out, I guess. Uh, 4 times 28, that's 4 times 30 minus 2 times 4. So that's 120 minus 8, which is going to be 112. Minus 40 root 3 plus 56 root 3. And then minus 10 times 2 is minus 20. Root 3 times root 3 is 3. So that would be minus 60. Okay. So 32 minus 8 root 3 plus 2. And then 112 minus 60 is something, 52. And then negative 40 plus 56, that leaves 16 root 3. Okay. So, what can we do? So, I don't want to square things yet again. Yes, it'll get rid of the square root sign, but it'll add in some more problems. What I'd really like to do is cancel this 8 root 3. So, let's just take a look at this part here. So 2 times 52 plus 16 root 3 square rooted. I think that should probably look like something like a plus 8 root 3 when all is said and done. But can I actually show that? Well, let's move on to the next page. So, now if I want this to look like a plus b root 3. More specifically, I want this to be 8 over here. Is that the case? Well, if I square both sides, I'll get 4 times 56 plus 16 root 3 is equal to a squared plus 2a8, so 16a, plus 8 root 3 squared, so that'll be 8 squared times 3, so that'll be 192. Oh, and I forgot a root 3 here. So this sort of has to be true in order to get an integer. We have to cancel out this 8 root 3 here. 4 times 56 is 4 times 50 is 200. 4 times 6 is 24. So this is 224 plus 64 root 3 is a squared plus 16a root 3 plus 192. I guess 16a has to be 64, and a squared plus 192 needs to be 224. So this would tell me that a is 4, and if I take a squared, that'd be 16. 192, and then 16, we get an 8, we get a 0, we get a 2. We don't get 224. So have I done something wrong? Probably, but what? Is this even the sort of expression that we want? Well, yeah, because if we don't cancel out the negative 8 root 3, we'll never get an integer. And this negative 8 root 3 is correct, right? 2 root 3 minus 10 root, yeah, it's negative 8 root 3. So we need this, 2 times this, to be something plus 8 root 3. We have to have that. Did I get the 192 wrong? 64 times 3, no, it's going to be 2, carry the 1, yeah, 192. 4 times 56, no, that's 224. Is 56 wrong? It's 52. That would be why. And that will be 208, which is exactly what we got. So 2 root 52. I'll just write, it must cancel with the minus 8 root 3. That's how we need to think of it, like this. So 2 root 52 plus 16 root 3 is really just 4 plus 8 root 3. So k squared is 32 minus 8 root 3 plus 4 plus 8 root 3, which is 36, and therefore k is 6, and we've shown that it is, in fact, an integer. There's probably... So we worked it out, we squared it because of those pesky square root signs, and then we didn't want to square it again because that would sort of mess up what we'd already achieved, but this minus 8 root 3 is just begging to be canceled if indeed it is an integer. This question, I think, would have been harder if they had just said, simplify this expression, but show it's an integer sort of, and I think quite nicely, leads us into saying, okay, now this part's got to be 8 plus a root, or 8. It's a plus 8 root 3. It's something plus 8 root 3 because we got to cancel that 8 root 3. So that's our motivation behind setting that up. But probably the 4 plus 2 root 3 and the 28 minus 10 root 3 could probably be done similarly. Say it's a plus b root 3 and find your a and b, something like that. But I like the way we did it here. I think we needed to have the 8 root 3 in order to cancel out. And so I think it flows a lot nicer. But, maybe there are other ways to do it. You don't have a calculator, so you have no idea what you're doing on this. And if you guys had a different way to do it, I would absolutely love to hear it. And that concludes question number 9. We just have one more question to go, and that'll be question 10. Ooh, it's the rare question 10 on the Manitoba papers that has a two-parter. Well, I cannot wait to see that. Feel free to give it a try before watching the next video, but I will see you next time for question 10.